I'm Dallin Marshall. This is Alex Wallentine. This is our ECE 3710 Microcontrollers final project. We'd like to give a shout out first of all to our sponsor Kimber Computers for sponsoring us, helping us get this thing going. Basically what we've done is we've taken this computer case and we are modulating the fans to control the temperature inside with input from temperature sensors like these. This was designed to save us power by not using the fans when we don't need them and cycling them up to cool key components in the motherboard. So I'll let Alex tell you a little bit about the interfacing that we've done.
So if you take a look over here, this is our LCD. It has temperatures, temperature sensors A, B, C, and D. It shows you their output. There's also a threshold temperature, which the user can adjust to go up or down.
Just like a thermostat.
Just like a thermostat, exactly.
Okay, so what we've got is we've got 3 fans. Number 1, number 2, number 3. 1 and 2 are outtake, while 3 is an intake fan. We have temperature sensor A, B, C, and D. We really wanted to just capture kind of the whole gradient of the motherboard so that we could really kind of analyze the data and figure out which combinations of fans best cool each part of the motherboard. So what we're going to do right now is we're going to start this thing up. Oh, whoops. Okay. So what's going to happen is this fan right here is controlled by the motherboard, just to take care of the processor. It kind of screams at you if you don't have that one in. But the other 3 are all controlled by the microcontroller. So right now you can kind of see that fan 3 right here is running while the other 2 are not. We're going to get a little bit different temperature schematics right now because the case is open. Like, it's not going to have the same attributes and flow. So right here we can see that it's trying to get to temperature sensor A, which we know actually cools best from our testing with only fan 1, because it just blows in the air and it kind of just rises up here. If we're sucking too much out of these 2, the airflow comes straight through and misses temperature sensor A. So that's what it's trying to do right here. It's got 1 fan going. We've also added priorities to the different areas. For example, this area right here is the highest priority because it's behind the CPU on the north bridge of the motherboard. We really wanted to make sure that that got the most priority. So we'll give you a little test run right here. We're going to ramp it down a little bit, and so the fans will kick up. So you're going to see these 2 start cycling because now this area of the motherboard that has the highest priority is the most important. And this fan over here is going to start going down. You can see with the LEDs that it is ramping down. We actually found that if we turned up all of the fans full blast, we got worse temperature characteristics in the case as if we cycled down the front, cycled up the top, and so we are constantly just cycling the different fans to keep it as regulated as possible.
And if you look over here, this shows you the percentage that each fan is on. So we have right now we have fan 1 at 100%. We've set the threshold pretty low, so it's ramped up to 100. And fan 2's at 100, and fan 3 is just at 6%. And it looks like it's pretty stable right now. Do you want to change it?
Yeah, let me change this a little bit. So what I'll do here is I'm just going to tell it, I'm going to raise this temperature because temperature sensor B just has so much priority for this area that as long as it's below the temperature sensor, or the temperature threshold, that it won't grab any of the other temperature sensors. This is the most important, and it's the hottest. So let me turn this up. We've also got it set to where it'll start ramping down the fans to conserve energy if it gets too far below the temperature. So over here, we can see that fan 1 is almost completely turned off, and fan 2 is almost turned off as well, but fan 3 is still going there to give us a little bit of circulation to the other locations in the motherboard. So this is the finished product. We got the monochrome LCD coming out the back with our temperatures and our thresholds, and we're able to see that it is all inside the computer case, just doing its job. We've got the fans back here and up here that are just cycling and doing what they're supposed to do. It'll do its very best to stay right at the temperature threshold. Thanks again. That's Dallin Marshall and Alex Wallentine. We'd like to give a shout out again to our sponsor, Kimber Computers, and we thank you for watching.